Hi friends, we are going to talk about PIC microcontroller instruction set. Before starting the PIC microcontroller instruction set, we will talk about what is PIC generally. PIC stands for Peripheral Interface Controller, which is being developed by micro technology, or I can say microchip technology, which gave the name as Peripheral Interface Controller. Earlier this PIC was called as PIC 1640 and PIC 1650, which was developed by General Instruments. Were called as Programmable Interface Controller, or later it has been called as Programmable Intelligent Computer. Today we shall just talk about the instruction sets of PIC microcontroller. The instruction set format can be divided into 5 different categories. They are bit-oriented instruction, byte-oriented, literal instructions, branch instruction and machine control instructions. Before going into instruction set, we will talk about some general registers. WR register, which is just similar to that of your 8085 microcontroller, which is an 8-bit working register which is equivalent to microcontroller, just your microcontroller 8085 or 8086. This used for the purpose of arithmetic and logical instructions. This bank select register, we have got 16 bank registers, out of which lower half is selected for bank registers and the upper half of the 8 is selected for RAM. The purpose of these registers is to select the banks and 12-bit address for data memory. Next one is file select register. You have got 3 different types of file select register, which are FR01, 0, 1, 2, and each file select register is composed of 8 bits, each of lower order and higher order. These file select registers are used as pointers for indirect accessing of your data. We will just talk about the instruction set of 18F722, which includes 77 instructions, out of which 73 instructions are one word and 4 instructions are of 2 words, and each word consisting of 16 bits. Now I will just generally divide into 9 different major categories. Move instructions, arithmetic, logical, branching, bit manipulation, test and skip, increment and decrement, table read and write instructions, machine control instructions. Now we will start with move instruction. The move instruction is, first one is move LW, where LW is nothing but the literal value is moved into the W register. For an example, I can just say move LW 80, some literal value I take. This literal value is moved into the W register. Now my W register will be having the value 80 after the execution of this instruction. Next one is move F comma W, where F represents your file register, where A can be, if it is 0 it can access the bank, if it is 1 it is accessed by the bank select register. For an example, I am just going to write move 25 comma 0. A 0 represents your access bank, that is your RAM address, where the data from the W register is copied to the file register. Next one is move F of source file to destination file, where the content of the source register is copied to the content of the destination register. For example, I can just move FW, Fs, Fd, where here the content of the source is moved to the destination register. Suppose let us have 025x and one register is 025, that's content is 01, and you have got another register called 20, which is nothing but your destination register. I have got some value as 02. What happens when I execute this instruction is the 21, the register 25, the content is copied to the destination register, where the content of 01 is copied to the content of this 020 register. Next one is, this is about move instructions. We will talk about arithmetic instructions, where add the content of add LW 8-bit, where the content of the literal value is copied to the W register. I can just give you an example over here. Where here the content of the literal value is copied to the W register and the content is added with the W register. Add literal W some 8-bit data. Whereas assume my 8-bit data is going to be 0F. Right? Here what happens is W register, the content of W register plus my literal value 0F. Suppose I have got 01 to be added with that of it. 10 is my W register value. Where when I execute this instruction, my W register content would be now 1F. Like that, you have got add WF, F, D, A, where D represents, if D is equal to 0, it will save in the W register. If D is equal to 1, it is saved in the file register. For example, I can just say you add WF 20x, 1, where I am going to use only my file register to save my content. Here the content of the W register and the content of register 20 are added it and my resultant is stored in register 20. Where add WF 020x and 0 if I give A to be 0 or my destination to be 0, here my content is saved in the W register itself. Next one is about multiplication instructions, where I have got two temporal registers called PRODH lower order and higher order, where the content of the literal value is multiplied with the W register and the resultant is stored in both higher order and the lower order values. And same for multiply with file register, and this is for immediate data. Here I am going to copy the content of W register and the file register, both are multiplied together and the resultant are stored in the higher order and lower order bytes. DAW is nothing but just like your DAA in 8085 and 8086, we will be moving the content of W register, we will just divide into split. It is an 8-bit register, where it is being split into 4 different bits, where BCD operations will be carried out, just similar to that of your DAA instruction in 8085. Next we will move to logical instructions. This shows you an AND operation, where AND LW 8-bit data, where I am going to immediately move my 8-bit data to the W register. For an example, I will just show you. Here this instruction is used for AND operation, where the content of both the registers are added and it is stored in W register itself. AND LW some 8-bit value 0F, let us assume, and my W register content is, let us assume, to be F0, right? If if I just execute this instruction, what will happen? My resultant is, just for an example, 110000, and I am going to just AND 0000 F11. I am sorry. If I AND both, my resultant would be 0. My W register will have, after executing this instruction, my W register will have the content 00. This is how this instruction is being executed. The same operation can be carried out with the W register and the F register, file register. Where, as I said you, if D is given, the content is equal to 0, the file is stored in the W register. If the content is D content is 1, it is stored in the file register. And this same operation can be carried out for inclusive OR and for exclusive OR. Then we will just move to branching instructions. Branching instruction, it is a type of short jump where the content is being moved from 128 bytes plus 128 bytes to minus 128 bytes. Where branch, if carry flag is set, the branch is transferred to the target address, which is given by the short address, which is in between 128 bytes to plus 128 bytes to minus 128 bytes. BNCN, where branch if carry flag is not set. BZN, where if 0 flag is set, it will move to the target address. BNZ means if 0 flag is not set, it will just move to the target value. Negative, if N flag is, if the negative flag is set, it will just move to the target address. BNN, if negative flag is not set, it will just move to the target address. B0, that is over flag is set, it will just move to the particular target address. If it is not set, it will just move to the particular. This go address is nothing but an unconditional jump where I can just transfer my data. It is ranges from 1024 bytes to minus 124 bytes. It can just move in between. It is an unconditional jump. Just like that, it can jump. This a type of branching instruction which consists of a subroutine call and return statements. R call is nothing but a relative call. Relative call, it can transfer between the memory of 1K, and it takes 16 bit 2 bytes of instruction, where out of which 5 bits are used for opcode and 11 bits are used for finding out the target address. Next one is when the particular instruction is being shifted, it acts as a push instruction where the particular program counter is pushed into the stack and the particular address, the target address, is moved to the program counter. Call 20 bits. It is a normal subroutine, whereas 12 bits are used for opcode and 20 bits for finding out your target address. Here, comma S represents the value. If S is equal to 1, we will say the W register, status register and the blank select register. Return, same, if I have a call, that should be a return statement. Call returns to the next instruction where it has to be executed. This return is from the interrupt. Next one is bit manipulation instructions. This bit manipulation instruction is used for BCF, F, B, A, where this is used for clearing the bit, particular bit. For an example, I can just say you BCF, suppose I want to clear bit port 5.5. I can just write BCF port 5.5. If I just write BCF port 5.5, it just means that port 5.5 is equal to 0. The particular bit of the port is made 0. Next one is bit set. The particular bit can be set. Toggle, particular bit can be toggle. If it is 1, it becomes 0. If it is 0, it becomes 1. Just rotate bit. Just like your RLC in 8085, we can also rotate the bits for particular, if one single shift will happen. This is RLCF is nothing but rotate carry through carry. This is RLC NCF is mean for rotate left not through carry. RRCF means you that rotation should be done through right, through carry, and the opposite way without carry. Next we will move on to table instructions. Usually a table read or write, whatever you do, first from the table pointer the data will be copied from the ROM memory, it will just move to the table latch, where I have got 4 different instructions which will just copy the data from the program memory in different ways. If I just read TBLRD star, where it will just read the data from the program memory to the table latch through table pointer. If I just have TBLRD star plus, the data will be moved from the program memory to the table latch through data pointer, and the data pointer will be incremented by 1. If I give this as just a minus symbol, the data will be copied from the program memory to the table pointer, and the table pointer will be decremented by 1. This instruction will give you TBLRD plus star. First my table pointer will be incremented by 1 and then the data will be moved. The same for your write instructions. Here the data from the table latch is moved to the program memory. Same, all the cases apply the same. Next one is machine control instructions. Here the function of watchdog timer is nothing but if any some mal operations happens in the software, this watchdog timer initiates. This can be cleared by using clear watchdog timer. Reset, if any sufficient voltage is not applied to a particular pin, this function resets. This resets all the flags, all the registers, all are been reset. This can also be reset by using a command using the pin called MCLR. Sleep, it just goes to standby mode. No operation, it does not do any operation, just to skip the particular jump period. Thank you.